very much for inviting me, giving me this opportunity to be here tonight. And it's lovely to have a bit of networking with Italy as well and see that the machine learning community is going very well and it's good ends. I'm Stefano, and I am machine learning engineer in TrustPilot. I'm based in Edinburgh in Scotland. Tonight, I'd like to talk to you about a nice experiment we run in TrustPilot, which deals with a software which deals with a framework whose name is MLflow. And it deals with a specific problem, which in my opinion is often neglected nowadays, and it affects the data science community quite a lot. And it's the problem of tracking. So through this presentation, we go through these points, why it's important to have a tracking and why we need to track data scientist experiments, how we can track experiments, and then a possible solution which comes from proof of concept and work done within TrustPilot to assist our data scientists. So we can start to say why tracking, what's tracking, what do we need to do? So I think that nowadays data scientists should be seen as wet lab scientists. So they do need a logbook. So what's a logbook? What's a wet lab scientist? What's going on here? I think there's a good similarity between data scientists and wet lab scientists. So here we have our wet lab scientist. He's used to work in the lab. And usually, as a data scientist, he can retrieve some raw data. For example, this can be a protein, somehow, some form, we don't know exactly how it's made or whatever. And usually a scientist starts to formulate some hypotheses. So for example, how we can find a drug to bind this protein, how can we improve this drug, how can we further exploit the protein structure. And what's going on here is that at some point, scientists going to start a cycle of experiments, and it's not a simple tiny cycle. It's like millions and millions of experiments every day. They all look the same, but they have different shades. Maybe they're changing something, they're changing just small concentration or whatever. And what's very important for wet lab scientists is to keep track of what they're doing. So they do rely on the concept of having a logbook. So a book where they can log all the experiments they've done, why, what was the hypothesis they were proving, and so on. What's going on often, especially for scientists, is they neglect the logbook, and the final result is the catastrophic no logbook effect, where you got a crazy scientist. This crazy scientist is very good in running experiments, but he's very bad in tracking his experiments. So he doesn't really know what he was doing and what he was trying to testing, what hypothesis and so on. So the same applies to data scientists. Usually, I think this is a common situation. Data scientists got some raw data like these ones, maybe with thousands and thousands of features. And from here, they start an iterative procedure which can encompass all these steps. So there's an initial work on the raw features. So they start to see how the features look like, what's the missing feature, what's the ratio of a feature with respect to another one. They're going to run some checks, sanity checks. They say, oh, I can merge my data set with another external data set. I can create a very big data set. And then from there, I can start to look at the features from another perspective. They do some mathematical operation on the features and so on. So they do quite a lot of work, initial work. And after this, there's definitely a part where they're doing some data analysis. So it's true that data scientists are able to run models, but before running a model, we need to check if the signal to noise ratio is good enough, if we can prove our hypothesis, if we can really find a signal that could help my model to have better prediction. So they run some analysis on the features. And then finally, maybe the real fun for data scientists, pick up a model and start to run a model. And all these steps are quite linked each other. It's an iterative procedure. Sometimes we start from simple Jupyter notebooks, then we modify tiny bits of codes. We forgot to commit our modification to GitHub. And so maybe we miss pieces of codes, and missing pieces of codes means also that maybe we're going to miss some answers, because sometimes it happened to me as well. I was looking for some hypothesis testing and I was able to prove my hypothesis, but then I forgot to commit and modify my code and I wasn't able to retrieve the previous answer. So as something, some things happen. And what's going on is that if we don't keep track of what we're doing exactly all the time, we are testing, especially in the very beginning of our experiments, we will end up in the no logbook effect. So crazy data scientist. So that must be said. After thousands of iterations, this is the situation. So we know that we have different folders, we have different models, binary files everywhere. It's even crazy if we have to consider further programming languages. So maybe we want to optimize already a feature transformation and we're going to use C++ or whatever. So we have different codes working together. As I said, we forgot to commit our codes to GitHub. And then we are full of plots, F1 score, confusion matrix, any kind of matrix we come up to our mind, because, it's a creativity process, this one. And so everything, any idea is always very good. So as you can see, data scientists are exactly the same as wet lab scientists. They do need a logbook. They do need to keep track of their experiment or what they're doing, why they've done so, in order to further strengthen their tests and prove their hypothesis. And usually I remember when I was a data scientist, I was very good in documenting my experiments, but as I said, sometimes I forgot to commit something. And we can be good to keep track of what we saved, our files and so on, but there are no doubts that we'd like to have a graphical interface to navigate towards all our experiments and towards the best experiment that we run in order to pick immediately the right answer. And also, it's very hard sometimes to have a simple piece of code in Python that I can import in my model code. And this basically triggers a process that's going to start to track my experiment. So for this reason, this was happening in TrustPilot as well with our data scientists, especially the very first iteration. So what we've done was to see what was on the table. So here just listed 3 possible solutions for the tracking problem, but there are obviously thousands and thousands. But these are the main one. One of them is ValoHigh. ValoHigh, it's a very good piece of code. It's specifically designed for a collaboration across your entire data team, and has been specially designed to create pipelines. So it's kind of fashion thing now to create machine learning pipelines and so on. Anyway, it's a good product. There are some prices to consider, obviously. A second product that I considered was CometML, and I love CometML, I must say. If you go on their website, they're saying that they're building machine learning like Legos. It's really true. What they've done in Comet is a fantastic effort to keep track of everything that you're doing with a fantastic user interface. The only problem is that you have to pay something. It doesn't come for free, and it's self-hosted. So they have their own cloud environment. So if you have for example, you're working in your GCP project, sometimes you're reluctant to go to other cloud-based projects, and maybe you have to do some VPC discussion with your security engineers and so on. So it's not always the best solution. What we found optimal is MLflow. MLflow is an open source platform, so open source should ring a bell. I think it's why fantastic to have a tracking thing like open source. It was mainly developed by Databricks. So all the Databricks developers started to put their hands on MLflow, and it has a fantastic integration in Python. So it's pretty straightforward, easy, exact on point. But if you want, there's also Java, R, and REST. So any kind of API you'd like. And being open source, the main thing is free. So if we give a look to MLflow, we have 4 different products. Tonight, we'll be focused on MLflow Tracking, which is to track experiments, machine learning experiments. But MLflow comes in different flavors. So we said there's MLflow projects. If you want to share data scientist code across various teams and you want to ensure there's reproducibility. And then there's also MLflow models, MLflow registry, which are linked together, and they should basically cover the gap between development and deployment. So these will allow you to go to production with your models. So how MLflow tracking works, that's pretty simple. It's just a Python package that you have to import in your code, and then you can start to log whatever you want. So for example, in this tiny code, I'm logging some parameters, creating some directory to put my text files, which will be logged as well. I can give you something more concrete, like here. So MLflow has a graphical interface. The graphical interface can be easily viewed on your local host or also on your local machine. But MLflow can also live on a cluster, on a dedicated server, so you can just go to your server, we'll see later. And as you can see here, they're listing clearly all the experiments that you've run, with all the runs that you have, along with the user that has run these experiments, the code which was used to run these experiments, and some metrics and parameters. If you pick one run, you can clearly see that here we got the parameters used for this run, the metrics saved. So this can be also plot if you are, for example, using neural networks and you're training your model across different epochs, you can have a plot here. And then there's this very important artifacts box, which keeps track of, this is my important file, of all the artifacts that have been created during your experiment. So as you can see, pretty straightforward to be used, nice user interface. So it's great, but it's a great product. But then we said, how can we help really our data scientists, and how can we introduce MLflow without being too disruptive? So one key point to keep in mind every time, especially for engineers, is that a company relies on some codes, and these codes maybe are very historical codes, so you don't want to really break them or reformat them if there's no need. You'd like to have a seamless introduction and integration of your new framework within historical frameworks, let's say. So what we decided to do in order to allow our data scientists to use immediately MLflow without modifying drastically their code was to create a wrapper around MLflow, a Python wrapper, so a simple Python package that they could use, and they could follow and do all the needs we had to satisfy. So I will not really go through all the details of implementation of the wrapper. However, if you're interested in it, there are some articles on my Medium account where I'm talking extensively about the implementation of MLflow in a wrapper, in an SDK, how to use it, trying to covering model development and model deployment as well, as you can see from this title. But we can simply focus on how this wrapper was done, and then if there's enough time or whatever, we can give a tiny look at the code. So our SDK was working in this way in a nutshell to have a super data scientist. The first thing to consider is a protocol that allows you to have obviously input parameters. So we can think of giving the data scientists to input thousands and thousands of parameters to keep track of their experiments. Few parameters, less is more, is always the best choice. So this is what we've done. We optimize our SDK in order to have just few input parameters like the tracking URI. So the tracking URI is the URI of where the MLflow lives. This can be your local host, or it can be also a URI of a specific server where MLflow lives. Then the tracking storage. So if you're using cloud, for example, and you want to save MLflow and models artifacts in a bucket, you can simply give here and everything will be directly to a tracking storage. And then some information about what you're running. So the name of your experiment, some tags, and color. It's very important. We will get to this in a second. The second step is, and the core of the entire SDK, is to be able to listen to training jobs. So just imagine the SDK has made with this protocol, read parameters and run training. Run training is the main function, and listen to data scientist code. Listen means that what's going on is, or something in the chat? Okay. Oh, thanks. So basically what's going on is that MLflow is being fantastically tuned to listen to your code. What it means is that before keeping track of all the information that are produced from your training job, we can trigger this autolog function. Autolog in MLflow is connected to a Python module, which is called inspect. And I think sometimes is really neglected. This module inspect allows you to do a lot of things. One of them is to listen to the code that is using the inspect model. Listen means that it's retrieving information like, oh, you're using scikit-learn classifier random forest. Okay, pick this up. You're using this metrics, using these parameters. I'm going to collect everything. It's like a recording session that is going on. And as I said, MLflow was developed furthermore to have autolog for specific projects. So for specific Python methods like XGBoost, scikit-learn, TensorFlow, and so on. So all these are perfectly tuned in order to listen and to extract exactly all the relevant information of your experiment through simply a few lines of code. And then here is the core of everything. So when we say MLflow start run, MLflow will start the recording process, will start to write on the MLflow server all the information that he's listening to the model code that is running. And finally, the last step that we implemented is to log further artifact and metrics. It often happens that data scientists are creating some ad hoc plots, ad hoc measures or whatever at the end of the training. So we'd like to keep track of everything that's been created in the training session, check all the files basically that we have in this local folder or container folder, and push it back to the MLflow server. So how does it work is in practice. So this is exactly how our data scientists were using the SDK, MLflow SDK. They were just simply importing our MLflow SDK. They were importing the interface that we exposed to use MLflow. Then they have exactly, the code was exactly as before. They just have to define the dictionary of input parameters that we saw. And then just before the model fitting, what was going on was that they have to start the training job. So by saying this, they were starting the recording session of the job, and then define end training job if they have further data they want to be saved that was created locally. And so what was going on was that the results were easily output on our dedicated MLflow server. And I can show you here that, for example, I ran just a few tests with a simple random forest. So to have a flavor of what the SDK and MLflow was doing was simply to have all the parameters of our random forest picked up, all the metrics. So I can show this metrics at the moment. This looks like a rectangle. As I said, if you are running in steps, you will see, you can plot the, for example, the metrics here with its steps. So you can see how it's going through as time goes by. And then the artifact box, which is very, very important. So what we have here, we tune our SDK in order to save the code. So I don't know if you remember, initially I told you about a caller input argument to be given. So we use the traceback Python module to keep track and save the code that was using our SDK. And so there will be no occasions where someone is basically running an experiment, he found some answers, and then he forgot to commit this code to GitHub, and he doesn't remember the code anymore. Everything will be saved, even the code. And as you can see, this is a simple script, but what we've done was, as I say, just before running the fitting, we ran the experiment tracking through our SDK. And then obviously the model was saved in a pickled format. This can be whatever format. And we saved as well plots in with Plotly in HTML format. This is very fancy because when you're ending up the experiments, we made the SDK to collect all the previous metrics from previous experiments within a single family and group them in a single plot. So you can immediately spot which is the run ID with the best, for example, accuracy score. And furthermore, we have our, for example, MLflow server in GCP. So data scientists could just simply SSH to the MLflow server and see the results in localhost. There's also the opportunity to add your model to a model registry, which is a database. And so you can keep track of all your models and if they are in development, in staging, or in production. And the very, very last bit, and I will not talk about this, however, is that MLflow gives you the opportunity to create custom deployment plugin. So plugins in MLflow can be thought as button that you can just click and actionate your deployment process. So this could cover the entire, the entire MLOps problem, and for having something more automatic to go to production. So let's sum up. So what we saw is that data scientists are experimental scientists, so they do need a logbook. It's very important to keep track of everything you're doing. Everything is very, very meaningful to find answers and prove your hypothesis. And one possible solution is MLflow, which is open source, can be easily integrated seamlessly in your codes. And yes, one solution is to start from where we were to the MLflow SDK and go even further. Yeah, that's me. Thanks very much for your attention.
Thank you very much, Stefano. Amazing presentation. Thank you. All the things that you have done and said today is like it's obvious, but nobody talk about the behind the scenes of a project.
Yes, absolutely. Yes, you're right.
Yeah, and thank you for sharing this amazing platform, this amazing tool, because now it's like, okay, this is going to save many lives and save time for many data scientists and data professionals. Thank you so much for that. And now, if everyone has any question, you can open your microphone, so you can write on the chat.
Versioning. This is a remarkable problem. So the real answer is that I can't remember off the top of my head how we were versioning in MLflow. However, you can definitely add tags to keep on versions. So if we see the experiment here, you can keep track of your version by simply add a simple tag like version something. So you keep track of, as well as per your, for example, think of your requirements. If you got some dependencies and so on, and you want to keep track of them, they can even be saved directly in the artifacts of an experiment. Model registry with Git. So yeah, for Git, if you want to couple MLflow with GitHub, basically what you have, you can simply use the CI/CD interface of GitHub. You can exploit Travis and set up a code which interacts with your model registry, and then ship these things to your production environment. This is what I could think. MLflow for Edge ML deployment. I don't know what you mean, sorry, for Edge ML deployment. If you're saying, if you can use definitely MLflow for machine learning deployment. As I said, there's the MLflow plugins, which are a good option. They need, however, quite a good work from your engineers, as there are obviously some dependencies and resources to make aware from your cloud environment. How does MLflow compare to sister tools in the market? What is the core feature to set itself apart? So MLflow, I think the key point of MLflow is being open source. So if you're a company and you really don't want to depend on anyone else, You can have MLflow, it's open source, all the code, you can structure as you want, you can keep it in your GitHub repo and say, engineers, you can work on this, you can structure these, we can keep our version in MLflow. And that's an absolutely is an asset if you have the opportunity. And the core features, I think, is a fancy user interface that can be integrated with a lot of tools, and also the entire suite of MLflow that could bring you to deployment. It's something to consider. Not everyone is really going to give you easy deployment things. And MLflow for TinyML, two good questions. Must confess, I don't know, but I think definitely yes, why not? I can't see any problem in this. So I'm not sharing the Python wrapper for obvious reasons, because there are some keys that we can share, but as I said on my Medium account, I don't have it here, sorry. You can find these 3 articles where, yeah, this one, not this one is for deployment anyway. 3 articles where I'm explaining in details what we've done, and you can have the code. So I mean, the code is there. There are the code snapshots. You can take the all 10 together, and you got basically what we've done. So secrets took apart. Secrets is just cloud infrastructure things that we can say. We love secrets. I love this one. Yes.
We all love secrets.
Yeah, you know, tiny secrets across companies.
Yeah, true. Any other question?
Hey, Stefano, this was really nice, man. Thank you.
Oh, you're very welcome. Thanks very much. Thanks. Oh, you were the question. Okay, thanks for your detailed questions. I read somewhere we can use generated artifacts for experiments to run model directly. We can use generated artifacts for experiments to run model directly. Yes, so good point. Yes, it's something I totally forgot to mention, but just because we didn't use it. So I'll be brief. When you have artifacts and you have your model artifacts in your artifacts box, MLflow, not in this occasion, I'm sorry, but if you install MLflow, I'm sure it will, where there are some specific files which can be read by MLflow, and you can spin up the Python MLflow client to read these files and rerun a model. So that's also very good, because MLflow can run a previous model that you've created. I think it's quite remarkable, and it's also very useful when you go into exploring the deployment trace. I think I'm explaining this Python thing in this article on Medium, where we're trying to run the predictions and we're using directly the MLflow client. Do you version your data as well? Ooh, data versioning. Oh my God. This is $1 million question. So data versioning is a great problem, and we should keep track of data versioning. You actually can. The idea is that you could, you know what, you could save your data in the artifacts of the MLflow tracker after the train has run. So you got your data files and you keep track of a version of them. I think, if I remember correctly, we didn't explore the data versioning, but that's definitely I think it's very simple to be added to the artifacts box. So